Algebra students, Mr. Lawrence here, and we're going to do one more video on graphing parabolas. We're going to make sure you know how to do it when the vertex is going to be above the x-axis and the parabola is opening upward, and of course when the vertex is below the x-axis and opening downward. So let's see here. Hold on a second. I wanted to show you this way. Okay, that'll do what I want it to do. Oh my God, negative a black line. There we go. All right, and we're going to look at a special, very special circumstance that happens once in a while. Okay, so first thing I'm going to do is find A, B, and C. A, B, C, easy as 1, 0, 6, right? Because there's 0 x's in the equation. All right. So I go to b squared minus 4ac, otherwise known as the discriminant. I'll have 0 squared minus 4 times 1 times 6. The value of my discriminant is going to be negative 24. There are no solutions. This parabola will not cross the x-axis. So now I go ahead and I find my vertex. X equals the negative of b over 2a. And so I'm going to get 0 over 2 times 1. Which is just 0. All right, now I plug 0 in here. And if I want, I can make a little input-output table. The math for this should be simple, though, at least for the vertex. I'll plug 0 in. And when I plug 0 in here, I get 6 out, right? So my vertex is at 0, 6. 1, 2, 3, 4, 5, 6. Now, by the way, just to reaffirm that I know this parabola will not cross the x-axis. 1, the discriminant is a negative number, so there are no solutions, which means it doesn't cross the x-axis, right? Okay. And then 2, you see this vertex here I just found. Well, sorry, I'm listening to some music and I've got it up a little bit too loud. Okay, so there's the vertex, and A is positive, so the parabola is opening upward. So there's no way that this can cross the x-axis. Now, I normally like to put 0 in my t-table, but I can't because my vertex is at x equals 0. So I'm going to put positive 1 and negative 1 in. Now, because of symmetry, if I go 1 unit to the right, I'll know the y-coordinate when I do my math. Well, if I go 1 unit to the left, I'll get the same y-coordinate. Well, which one looks easier to work with? The positive one. So I'm just going to plug 1 in here. So I'm going to get y equals 1 squared plus 6. 1 squared is 1 plus 6 is 7. So I know 1, 7 is on my parabola. Well, then I also know negative 1, 7 is, and I don't even have to do the math. If you want me to, I can. But because of symmetry, it's going to be the same. I'll tell you what, I'll do it right here. It's very simple, but just to demonstrate, I'm using symmetry. So y is going to equal negative 1 squared plus 6. Y is going to equal negative 1 times negative 1 is 1 plus 6. And so I get 7, just like I did. All right, now to draw my parabola, I just do a little U going through here. And I'm not so bad at drawing them when their points are this close together. All right, so let's go on to problem number 2. Again, I'm going to find A, B, C. Easy as negative 5, 4, negative 2. Now I know this parabola is going to open downward, right? Because A is negative. So I go to my discriminant, B squared minus 4 times A times C. Well, this would be 16. I'm going to get a negative when I multiply, and I'm going to get 40. This is going to be a negative number. This problem will not cross the x-axis. So, again, I go to my vertex, right? And the negative of b would be negative 4 over 2a, which would be negative 10, which is a positive 2/5. Okay, or you could use 0.4 if you really wanted to. All right, so I'm going to go to an input-output table. Of course, I know my axis of symmetry, I didn't mention it on the last problem, but it's at x equals 2/5, right? I'll put that axis of symmetry in here. Let's see, I'm going to have to make this broken line thinner to tell how accurate I'm being when it's big and bulky like this. It's hard to determine the accuracy of it. Alright, so there we go. Okay, so let's get back to the input-output table. And I'm going to put 2/5 in, or 0.4 or 4/10. Okay. So I'm going to have y equals -5 times 2/5 squared plus 4 times 2/5 minus, I can't remember, 2. All right. So let me see, this is going to be -5 or 1 times 4/25, right? And that's going to simplify right away. The 5 is going to go into there 5 times. And so I'm going to get -4/5 for this first part here, plus 8/5 minus 2. And so I'm going to combine these 2/5 and get 4/5 minus 2. And I'm going to think about it as 2 minus 4/5, right? And so I'm going to get a 1, and I'm going to make this whole 1/5. And it's going to be a negative in this case because the -2, the 2 is negative and the 4 is positive. So I could change it like this, so it's more accurate. So we're going to get -1 1/5. 1.2 on your calculator. So 2/5, -1 1/5, -1 1/5. Probably right about there. Now I know the parabola is going to open downward, so I'm going to write this point above it, 2/5, -1 1/5. All right. Now I can plug 0 in. I'll get 2 out, right? And then to get the same point, I'm going to plug 4/5 in. Because this is 2/5 away from 0, so I'm going to go 2/5 away from there. 2/5 and 2/5 is 4/5, and I get the same number. And so it's going to, oops, I put that at the wrong place. It's going to be on 2, but it's going to be over at 4/5 or 0.8. Notice it wouldn't have looked symmetrical hadn't I switched that. And then my parabola is going to do something like this. Okay, there we go. Hold on, my music stopped. I'm going to restart it. Good song, by the way. Okay. So here's an unusual situation. Now, if you didn't know what I'm going to teach you, you would have to FOIL this. Do quantity of x plus 1 times the quantity of x plus 1, and then combine the constants together. But there's something really cool that happens here. I'll tell you what, I am going to FOIL it, and then I'll show you the cool thing. Okay, x squared plus 2x plus 1 plus 3. I just FOILed that. That's how that FOILs, okay? Then I've got two like terms here, so I'm going to get y equals x squared plus 2x plus 4. Okay? Now, I'm not going to go through the whole thing. I'm just going to go and find the vertex. So let me write down a, b, and c. Easy as 1, 2, and 4. And then the vertex will be the negative of b over 2a, which I believe will simplify to -1. So, on my input-output table, I get -1 for x, for the x coordinate of my vertex. And when I put -1 in here, I get -1 plus 1 is 0. 0 squared is 0, plus 3 is 3. Now, so I go -1, 1, 2, 3. That's my vertex, right? So -1, 3. But check this out. I did all this work, But when it's in this form, I can tell my vertex just by looking at the equation. The original equation. It only works when it's in this form. Look at this. -1. If I take x plus 1, set it equal to 0, and solve for x, I get x equals -1. And right here, my 3, let me clone him because I don't want him to leave the table. At least not till he eats his vegetables. Alright, so look at that 3. Yeah, the coordinates of my vertex are sitting here. I have to solve for 0. And there's the y-coordinate just sitting there. It's very much like when we did absolute value graphs, right? When we had y equals the absolute value of x plus 2 plus 4. Remember, the vertex was found at -2, positive 4. It's the same thing. Now, I'm not going to get a V shape. I'm going to get the U shape because my equation is quadratic and not linear. But that's it. You can tell the vertex. Now, once you know the vertex, you still have to go to the input-output table. But, you know, I can plug 0 in. Okay, and so this will be y equals quantity of 0 plus 1 squared plus 3, which will be 1 plus 3, which is 4. So 0, 4 is on my parabola. And now I can go to -2, same distance on the other side, and I'll get 4 again. And I don't have to worry about doing any difficult math. Working smart, not hard. I gotta tell you, I drew a parabola for my honors class in a video. And the vertex is somewhere way down here, and the zeros are like up here. And well, that couldn't be possible. Let's see, 1, 2, 3. 1, 2, 3 would have to be like this because of symmetry, right? Hopefully you're paying attention to that. And I drew it like, not perfect, but I drew it pretty darn good. I was so proud of myself. I think I did a cartwheel. All right, let's do one more here. Now, again, it's in this form where it's got that foiled quantity, or a quantity that wants me to foil. But I'm not going to foil it. I am going to find the vertex right off the bat. And I'm going to ask myself, what makes this 0? Well, 5 does. What number is sitting here at the end? 1. This vertex is at 5, 1. 1, 2, 3, 4, 5. 1, just like that. Okay, so I can go to an input-output table. I'll put 5, 1 in there just to show the symmetry. And then I'm not going to put 0 in, because if I put 0 in, I'm going to end up way off the graph. I guess I could. I'm going to go ahead and put 4 and 6 in. And you're thinking, well, 0 would be easier. Maybe not. Watch this. Okay, y equals 6 minus 5 squared plus 1. 6 minus 5 is 1. 1 squared is 1. Plus 1 is 2. That wasn't very difficult, was it? 0 would probably be about the same amount of work and a chance of a sign error. So in this case, I'm not going to put 0 in. Why? Because it was written in this special form. All right, so if I go 1 to the right, it goes up to 6. If I go 1 to the left of the vertex, it's going to go, excuse me. If I go 1 to the right of the vertex, it goes up to y equals 2. If I go 1 to the left of the vertex, it'll have to go up to y equals 2. And there's my symmetry. And now I can draw my parabola. And it's Sunday morning and my tummy is grumbling and my son wants me to go eat breakfast. So I am going to say bon appetit, which means good meal to you. En français, Mr. Lawrence signing off. Have a good night, everybody.